Alright, we know quite a bit about exponents up to this point. We know how to deal with a basic positive exponent. We know how to deal with a negative exponent. A negative exponent reciprocals our base, and so we get 1 over 81 in this case. We haven't talked about how to deal with a fractional exponent. Okay, so when we're in doubt about something and how that works, we can go to our calculator and try to see if we can figure out what the calculator is doing to get the answer. So let's go 9 to the exponent 1/2. That's coming out to 3. Let's do 8 to the 1/3. That's coming out to 2. Now if you think about that, you might recognize that what's happening here is that we're getting a square root of 9. And what's happening here is we're getting a cube root of 8. And so what happens with fractional exponents is that this bottom number is really the index on a radical. Remember, an index of 2 isn't usually represented, but that's a square root. And so in general, we can say is equivalent to the mth root of a. Alright, let's take this one step further. What if we have 8 to the 2/3? Well, what I could do is I could write that as 8 to the 1/3, all squared. The reason I can do that, remember, is that when I have exponents like this, I would multiply them. So 1/3 times 2 is really 2/3. And then we just talked about the fact that 8 to the 1/3 is the cube root of 8. So we would do that, and then we would square the whole thing at the end to get 2 squared. And so even more generally, if we have a to the n over m, then the m is the index, and the value on the top of the fractional exponent is the exponent on the radical. Okay? And actually that's even equivalent to that. Okay? This is your main summary of how all of these things fit together. So let's just do a few examples to get a better feel for how this works. So if I have 1,000 to the 2/3 exponent, that's equivalent to a radical with an index of 3, a radicand of 1,000, and then the entire thing is squared. So this is just a conversion process from exponential form over to radical form. Alright, the cube root of 1,000 is a perfect cube, that's 10, and then squared would be 100. Alright, let's do 0.25 to the 1/2. Okay, well, 0.25 is a quarter to the half. A half exponent is a square root of a quarter, all to the first exponent. And we want the positive square root, so that's a half. 81 to the negative 3/4. So now I'm throwing in a negative exponent as well. And remember from what we talked about earlier, a negative exponent means the reciprocal of the base. So this would be 1 over 81 to the positive 3/4 exponent. And then converting our fractional exponent to a radical, this would be the 4th root of 81, all to the power 3. 4th root of 81 is perfect. If I think about it, 3 times 3 is 9, times 3 is 27, times 3 is 81. So this would be 3, and then cubed would be 1 over 27. Just another couple of examples to show you the range of possibilities. 16 over 81 to the exponent, Let's do another negative exponent. Let's do negative 3 over 4. Alright, well, the negative exponent tells me to reciprocate the base, so this is 81 over 16 to the positive 3/4 exponent. And then the 4 on the bottom of the exponent is the index of the radical, the 4th root of 81 over 16. And then we're going to take the whole thing to the exponent 3. Alright, so if I'm doing this without a calculator, we should expect that these will work out perfectly. The 4th root of 81 we had in the last example was 3. The 4th root of 16, 2. 2 times 2 times 2 times 2 is 16. So we have 3/2 cubed. And then we apply our exponent rule, the exponent to the numerator and the denominator, 3 cubed over 2 cubed, which is 27 over 8.